Hello engineers, welcome to a new video on low-level design. In this video, we're going to build an elevator system using low-level design. I hope you're ready. Let's get started. So before we begin any LLD question, we need to first understand the scope of the problem because a system can be quite simple and it can grow to a quite complex system. And we don't have all the time in the world, so we need to narrow down the scope and only design for that scope, right? So if you already have a scope, work with that scope. If you don't have a scope, don't try to come up with your own scope. Derive the scope from your interviewer or any stakeholder or any online resource, right? So try to get the scope and then design for that scope, right? So for this video, this is the scope of the elevator system. Design and implement an efficient and scalable elevator management solution for multi-floor buildings. The system should handle multiple elevators, optimize elevator selection based on user requests, and provide real-time status updates to floor panels. So when we are given a scope like this, instead of directly jumping into the class diagrams, let's try to envision the user journey. We need to put ourselves in the shoes of the user and travel with the user along the way and see what all things we need to design the system, right? For example, I am a user and I'm walking into a building and I see outer panel for requesting an elevator. So that's the first thing I need. I need an outer panel which might have two buttons for going up and going down, right? And then once I hit the button, I can envision that a request is being sent somewhere, probably to multiple elevators, and then one of the elevators will come to me. So here I'm thinking if the request is going to multiple elevators, there might be some confusion. So there needs to be a middle guy somewhere who will take care of managing the elevators, right? So I'll probably need an elevator manager. And then the elevator itself is the next thing that I will need because it will come to me and then I can go inside. And once I go inside, there is an inner panel where I can request a floor number where I can go to. Maybe there are more people along with me. They're requesting their own floor numbers. So the elevator needs to go in some particular sequence. So what I'm saying is we need a queue for this particular elevator, right? And the final piece is provide real-time status updates to floor panels, right? So somehow each elevator should communicate back to the outer panel, which means that the elevator needs to maintain a state about where it is currently, and then that thing needs to be broadcasted to all the outer panels because the elevators can be in multiple floors and each outer panel needs to know which elevator is in which floor so that the elevators can act accordingly, right? So this is the scope of the system. So this is the class diagram for this scope. We have an outer panel which will pass on the request to an elevator manager who is responsible for managing multiple elevators and then choosing the right elevator for processing the request. And then we have the elevator itself, which will have some kind of a state. It can be in a moving state, it can be going up, going down, or it can be in an idle state, right? And within this elevator, there is some kind of a queue using which it is able to process each request. And then as it is changing state, the same thing needs to be communicated back to the outer panel. So these are my three main pieces: an outer panel, an elevator manager, and an elevator, right? And now let's see the remaining pieces. So the elevator is the only moving piece here. It is traveling between states. It can be in an idle state, it can be in moving up state or moving down state, right? So these are my states, and since these states can be extended, I would like to use a state design pattern here so that the states can be managed efficiently, right? And then there is this piece called elevator selection strategy because the elevator manager is responsible for choosing the right elevator for the right request. But how is it going to do so? There needs to be some strategy, right? And this is a behavior problem. So when we have multiple ways or strategies to solve a particular thing, we can make use of the strategy pattern. So how do we do that? We simply create multiple strategies. One strategy can be nearest elevator, where depending on the floor from where the request has come in, the nearest elevator will be asked to go there, right? Another thing can be load balancer. We'll see the load of individual elevators and find the best optimal elevator to process the request, right? And there can be other strategies like this as well. So because there can be multiple possible ways to do this, I want to use the strategy pattern, and then while creating the elevator manager, I will choose this strategy up ahead so that it can use that strategy and call upon the most optimal elevator, right? And then we have the outer panel, which will need to be updated upon every state change in the elevator, right? So that's why we can use the observer pattern here, which is similar to a pub sub model. So the outer panel will subscribe to the elevator changes. So how do they do that? While creating the outer panel, they will get added to the list of observers in the elevator manager, and elevator manager will provide a notify method which will be called by the elevators. So each elevator will call this notify method whenever there is a change in state, right? And then this notify method will internally notify to all the outer panels, and they will update their respective displays or whatever, right? So here we can see the usage of the observer pattern, right? So this is the whole idea behind the elevator system. So let's go through them individually. So the outer panel will have the elevator manager, and there can be multiple outer panels like this, and each panel will have the elevator manager class, and then every panel will be associated with a floor number. And there is only one method for this outer panel, which is request elevator, and it is providing the direction. Direction can be an enum with up or down, right? So user can request an elevator from the outer panel, and then this request is going to this method add to queue with floor number and direction from the outer panel. And then here we will call upon the strategy which will be available within the elevator manager, and we will choose the nearest elevator. So for that elevator, there is an internal queue. So this request will be added to the queue of the elevator, and then that will be processed within the elevator. So how will it process? It will maintain a queue and keep on processing one request at a time, right? So as it goes along the request, it will keep on changing the state. Maybe first it is in an idle state, and then it will change to move up state, and then when it's reaching the floor, it will come back again to idle state, and so on. So there is a change of state here. So whenever there is a change in state, we will call the notify method from the elevator, which will be updated to all the outer panels, right? So that's how the sequence goes. And then there are some helper methods: add elevator, add panel, and set strategy. And here we have the set state for changing the state of this. And then here we have get current floor, so that the elevator manager can make use of this to check the current state of each elevator, and then choose the nearest possible elevator or the most optimal elevator in the strategy, right? So this is our class diagram. Now let's see all this in code. So first let me show you the usage, then we will see the important pieces in the code, and then this code will be available in GitHub anyway, so you can explore on your own, right? So we have one elevator manager, which is a singleton, and then there can be multiple elevators: new elevator 1, new elevator 2, right? And then we are adding the elevators to the manager. That is the first step. And then we are creating the outer panels. So there are 3 floors. There can be outer panel 1, outer panel 2, outer panel 3. And these panels are also added to the manager, right? And then now we can do the request. So first, panel 3 is requesting an elevator with the direction down. So here what happens is the request will go to the elevator manager, which will be passed on to the strategy. Strategy will choose one of these elevators, which is the nearest elevator, and then the elevator will change its state, and then the panels will be notified about the change of state, right? Similarly, the next request is from panel 1 and then panel 2. So in the simple implementation, I have used a sequential request, but in a real-time scenario, there will be multiple requests, parallel processing, and so on, right? But our idea is to learn design patterns and do simple LLD. So I kept it simple for that reason. So let's run this and see how it looks like. So first we have the elevator manager created. So these are the creations for elevators and panels. So first panel at floor 3 is requesting elevator, request received for floor 3 in the manager, and elevator 1 is received request for floor 3, which means elevator 1 was the chosen elevator, and then elevator 1 is processing request, elevator changing state to moving up. Elevator is moving through the floors. It started at first floor, then it goes to second floor, then it goes to third floor, and every step of the way that change is notified. And then elevator 1 changed state to idle, which means it reached floor 3, and then this request is completed. Similarly, there will be other requests, panel at floor 1 requesting elevator. Now elevator 2 is chosen for processing, but elevator 2 is already on floor 1, so there is nothing else to do. The door will open and they can go in. Then the third request is panel at floor 2. So request received for floor 2, elevator 1 is received request for floor 2, and then elevator 1 processing request, changing state, going to floor 2 and then changing state back to idle, right? So this is how the system goes. Now let's see some important pieces here. So one of the important pieces is the elevator selection strategy, right? So for this, we are using the strategy pattern, which means there is a class with a method called select elevator, which will be a virtual method, which will be implemented by one or more strategies. So here I have implemented one strategy, which is nearest elevator strategy. So what is the algorithm for this? Let's say I'm getting a request from floor 2. So I want to measure the distance from floor 2 to all the elevators. So let's say one elevator is in floor 3, so the distance is 1. Maybe one elevator is already on floor 2, so the distance is 0, and so on. So I will check this state and distance for all the elevators in a linear time operation, and then I will choose the elevator with the nearest distance, right? So that's how this function goes. So we are using a for loop, we are going through each elevator, and then we are calculating a distance. So what is the difference between the requested floor minus the elevator's current floor? So this is the target floor, right? And then we keep track of this shortest distance, right? So we keep updating this shortest distance as we go along this loop. So at the end of this loop, we will have the shortest distance and the nearest elevator, right? And we will simply return the nearest elevator. So that's the idea behind the nearest elevator strategy. And next we have states. So first we have idle state. From idle state, if you are calling move up, then it will create a new moving up state with that elevator and call the set state method on that, right? So we have already seen the usage of state pattern in our state design pattern video. If you haven't watched that, definitely check it out in this playlist. And then similarly from idle state, we can go down. So we will create a new moving down state object and call set state on that. And then similarly, from moving up, we can call stop. It will call the idle state class and then create an object for idle state and then use set state to set the elevator to stop state, right? So this is how the state management works. Now let's see the other one. So the last big piece I want to show is the elevator manager class. So the elevator manager class has a bunch of elevators, have a bunch of panels, and also has a bunch of observers and also the selection strategy, right? After that, we have notify observers. So this is the method I was talking about for notifying all the floor panels about every state change in the elevators, right? So the elevator manager is holding a list of observers in this vector. So how are observers coming here? While we are adding a panel like this, right? While we are adding a panel, we are adding the panel to the panels list, and we are also adding the same panel to the observers list, right? Because every panel is also an observer. So when we are calling notify observers by any of the elevators, we are going through this list of observers and then calling the update method on those observers. So within this update method, they will update their own displays, right? For each elevator. So that is how the observer pattern goes. So far we have seen 3 patterns: state pattern, observer pattern, and also the strategy pattern. So those are the main patterns for this implementation. So this is the code implementation of the elevator system. The rest of the pieces are quite straightforward to understand, so I will leave it to you to explore. So if you have any questions, definitely put them in the comment below and I will try to explain it further for you. And the code is always available on GitHub. Definitely check it out, fork the repo. Try to add your own changes to it. Maybe add more elevators, more panels, and see how it works. Maybe add a new strategy for load balancing. Maybe add emergency stops or maintenance stops and so on, right? So the scope can be endless. So the idea is to practice design patterns. So I try to keep the scope simple. I hope you found this helpful. So please leave a like if you found this helpful. If you have any questions, definitely ask me. Don't forget to subscribe to the channel if you haven't done already. Thank you so much for watching, guys. I will see you in the next one. Cheers.